All right, welcome everyone to Rational Functions Lesson 3. This is obviously our third section here. We're going to be looking at how to write an equation of a rational function given the graph of that function. So we've learned how to graph a function from an equation, and now we want to look at writing the equation from the graph. All right, so let's look at a very brief how-to. First of all, just as with the equation, you need to figure out your x-intercepts, y-intercept, vertical asymptotes, horizontal asymptote, any holes that might exist, and we're going to use those pieces to create the equation. We know that the x-intercept comes from the numerator, so that's going to help us write the numerator. And we know the vertical asymptotes come from the denominator, so that's going to help us write our denominator part of the function. And then the y-intercept and the horizontal asymptotes are going to help us determine the final form of the equation. And you'll see what that means as we get going here. So in the numerator of your rational function, we are going to write the factors pertaining to the x-intercepts. So what I mean by that is if we had an x-intercept, let's say we graphed a function, and that x-intercept was out here at 3. That means we had a factor of x minus 3 because plus 3 is the 0. It's the same idea that we used when we were looking at polynomial functions in the previous unit. All right, so that's what we're going to be doing with the numerator. Our denominator is we're going to write the factors pertaining to the vertical asymptotes in the same fashion. If our vertical asymptote was here at positive 3, then one of our denominator factors would be x minus 3. And then we're going to check the y-intercept and the horizontal asymptote of that basic equation. And what we do is what we call compensate, what I call compensate. And we're going to compensate by multiplying if necessary. All right, so what we're going to do here is we're going to look at our first example now. So we are going to look at this one right here. And we are going to start by setting up a function. We're going to say f of x is equal to some rational function. So what I need to first find here is that my x-intercept is 4, and it's the only x-intercept on my graph, so that means the numerator needs x minus 4. All right, that creates an x-intercept of positive 4. Then we need to look at the vertical asymptote, and we know that that vertical asymptote is x equals negative 2, and therefore we need an x plus 2 in the denominator. Now, that is the preliminary piece. There's only one vertical asymptote, so there's only one thing in the denominator, and there's only one x-intercept, so there's only one thing in the numerator, or one factor. But then what we need to do is we need to compensate if necessary. So I need to figure out in the equation given, f of 0 is negative 4 over 2, which gets me a negative 2. The problem is the graph has a y-intercept of negative 4. But I know if I took negative 2 and multiplied it by 2, I would get negative 4. That right there is your compensation step. I need to multiply the whole equation by 2. That actually also creates the correct horizontal asymptote. When we look at this and we say this is x to the first over x to the first, the horizontal asymptote is the ratio of leading coefficients, and in this case it's 2 over 1, which gets me my horizontal asymptote of 2. So what we could do is to simplify this. This part is not absolutely necessary, but if I distributed the 2, I would get 2x minus 8 over x plus 2. and we would have our final answer. All right, so notice that one is the relatively easy one. It only had one vertical asymptote and one x-intercept, but obviously we need to make them a little bit more challenging. And our next one is going to look like this. But the same process applies. So we're going to start off, wish that would stop doing that. We're going to start off with f of x is equal to some rational function. And I'm going to find any x-intercepts. In this case, we only have one, and we have two y-intercepts. All right, so the x-intercept of -1 tells me that in the numerator, I need x plus 1. So that creates the x-intercept of -1. In the denominator, I need 2 factors because I have 2 vertical asymptotes. And the first one here on the left is -3, so that needs to be plus 3 here. And on the right-hand side is x equals 1, and therefore this needs to be x minus 1. All right, so what we will notice is the denominator has a higher degree than the numerator. The degree in the denominator is 2, and the degree in the numerator is 1. And therefore, our horizontal asymptote is here at 0. You can't see it, but there is a dashed line in there. Then we need to check our y-intercept. If I plugged in 0, I get 1 over 3 times -1, which is -1 third, which is -0.3 repeated, and that is this decimal here, our y-intercept. That means there is no compensation needed. So this is our final result. There's no multiplication needed, but if we finish this by foiling and simplifying that, or multiplying those two binomials, the numerator is x plus 1. If I get x times x, that's x squared. And through the process of foiling, we get a minus 1x and a plus 3x, which is a plus 2x. And 3 times -1 is -3. And we have a final answer for this rational function. All right, we have one more example to finish up here. And it's going to look like this. All right, so again, same idea. We get f of x is equal to a rational function. Notice we have 2 vertical asymptotes, and we have 2 x-intercepts. So that means in the denominator, we're going to have 2 factors, and in the numerator, we're also going to have 2 factors. All right, so in the denominator, if we look at our vertical asymptotes, again, we have -3, so that's going to be x plus 3 in the denominator. We have a positive 2, which means that's going to be x minus 2 in the denominator. Here we have x equals -1 as an x-intercept, and so we get an x plus 1. And the 0 is also an x-intercept, and therefore it's technically x minus 0, but we normally write that as just simply x, because x minus 0 is just x. All right, so now we need to double check. Well, the y-intercept is 0, so if we just did that really quick, we said f of 0 is equal to 0 times 1, which is 0 plus 1, over 3 times -2, and I get 0 over -6, which is 0. That means I have the correct y-intercept, but we need to check the horizontal asymptote. The horizontal asymptote is supposed to be at positive 3. And currently, because I have x squared in the numerator and x squared in the denominator, if you were to multiply what is there right now, we would get x squared plus x in the numerator, and we would get x squared plus x minus 6 in the denominator. And right now, because the degrees are equal, the ratio of leading coefficients is 1, which means my horizontal asymptote is 1. So the problem is it needs to be 3. So I'm going to compensate by multiplying. Instead of having a 1 in the numerator, I should have a 3 in the numerator. So I'm going to multiply up here by 3, and then we are going to simplify our equation, or rather multiply and get polynomials unfactored. So we're going to say f of x equals, we get 3x times x, so we're going to take this guy here, and we're going to distribute on top of that. So we get 3x times x, which is 3x squared, and 3x times 1 is 3x. And then in the denominator, we have already FOILed that together. We get x squared plus x minus 6, and we have a final answer. So those are the 3 examples that I have chosen for us. It's how to write an equation given the x-intercepts and the vertical asymptotes, and we can compensate by multiplying if necessary. All right, I am going to leave us with that, and I will leave you with this, a nerdy math picture. And I hope you guys learned stuff today that will help you both graph rational functions and also really pay attention to what's happening on a rational function and write their equations. All right, I will see you guys later.